It is the most powerful force in the known universe. Maybe not forever and for always, but at least for right now. We sometimes fail to appreciate just how impressive that thing is because when you hear the word intelligence, you think of book smart sort of things like calculus or chess or good memorization of stored facts. Other stuff that happens in that mysterious gray lump up there includes persuading other people to do what you want, reading other people's faces, making long-term strategic planning of your life, and any number of things, of functions that you might have in your brain the idea that smart people aren't supposed to necessarily be good at this, and yet whatever it is that these smart people are not supposed to be good at, like coordinating your love life or whatever, it's taking place inside your brain as opposed to, say, your kidneys. The hidden, overlooked power of intelligence that we don't even see anymore because we sort of take it for granted in the invisible background includes fire, language, nuclear weapons, skyscrapers, spaceships, money, and science. That big gray lump up there is some powerful stuff. So if I show you this grid over here, and I sing that ancient chant, one of these things is not like the other, one of these things doesn't belong, can you guess which one is not like the other, before this song goes on too long. And yes, this one does not belong. See, all these things sound really neat and futuristic and cool, but there's only one of them that is a cognitive technology. And the brain, let us remember, is the source of all technology in the first place. So if you've got interplanetary travel, it's cool, it's awesome. I'd like to visit Mars someday, especially since my father always claimed to come from there. He had business cards saying he was from the Martian government in exile, but I digress. One of these is a cognitive technology. It can potentially produce new technologies. It's a violation of a regularity that's held for the last 50,000 years, which is that all the change over that time has occurred in a roughly constant human brain. Now, there's an ongoing debate about exactly how much change has occurred over the last 50,000 genetic years, but whatever has been going on, it hasn't doubled our brain size. It hasn't re-architected the brain. We've all still got the same basic brain areas now and then, and the way I know that is that we've mostly got the same basic brain areas as chimpanzees. Robert Heinlein has said a number of controversial things in his life, but nonetheless, this one seems worth quoting. Super people are super thinkers. Anything else is a side issue. In particular, curing cancer. It would be a wonderful thing, no mistake, but the shape of our world is something that proceeds ultimately from the brain. And if you want to know about the shape of tomorrow, you're going to have to look at things that affect the brain first. Intelligence is the most powerful force in the known universe. We see the effects every day. It's the most confusing question in today's science. Ask 10 scientists, get 11 answers. And it's important to emphasize that it's not actually a complete mystery. As a friend of mine named Tom McCabe once said, anyone who claims that we are completely ignorant of the brain should be hit upside the head with the MIT Encyclopedia of the Cognitive Sciences, all 957 pages of it. If you look at a lot of the rhetoric that you hear about intelligence or the C word, consciousness, in today's philosophical and non-philosophical literature, you will hear some things that sound remarkably similar to this from an earlier time when life and biology was the same sort of mystery to us as intelligence is now. It's Lord Kelvin, poor guy. He said a bunch of things that were perhaps a little bit uncautious and will be the source of fun, stupid quotes to recite for the end until, well, the end of the human species. And it goes like this. The influence of animal or vegetable life on matter is infinitely beyond the range of any scientific inquiry hitherto entered upon. Its power of directing the motions of moving particles, in the demonstrated daily miracle of our human free will, and in the growth of generation after generation of plants from a single seed, are infinitely different from any possible result of the fortuitous concurrence of atoms. Modern biologists were coming once more to the acceptance of something, and that was a vital principle. Well, they didn't come to that acceptance for very long. The thing that really strikes me about this paragraph over here is I like that sort of infinitely different part. It's a sort of pride in not knowing something. Lord Kelvin got this big emotional kick out of his own ignorance of biology, and there was a quote I was going to use here, but someone seems to have recited it before my talk about mystery being in the mind, not in the environment. I am ignorant about a phenomenon that is a fact about my state of mind, not a fact about the phenomenon itself. That's not my idea. It comes from E.T. James. It's an instance of what philosophy students will have already identified as humane projectivism. So Lord Kelvin did not know how life worked. He mistook this for a positive knowledge upon his own part that it was a inherently mysterious, inherently intractable, inherently unsolvable problem. And you will hear a lot of rhetoric resembling this when you listen to people talk about how much we don't know about intelligence. And so remember, if you don't understand intelligence, that's not a fact about the brain, it's a fact about your brain. So, what do I think I know, and how do I think I know it? Future's not very predictable, but it does seem safe to say, based on what little we know, that the space of human minds is immensely smaller than the space of all possible minds. This is something that we can sometimes tend to lose sight of, because in our daily activities, we come into contact only with other humans. So for us, the variation within humans is the sum of the variation within our experienced cognitive world. It's the sum of the variation in the other minds we try to model. But this is just because at this present time on the planet Earth, for a short while longer, we are in this rather anomalous state where the only kinds of minds we have ever encountered are human ones. And that is a very tiny set of the range of possibilities. It makes us think that the customs of our own island are the laws of nature, as it were. I also put that little dot near the bottom of the scale. What do I think I know, and how do I think I know it? Well, even though the future is in general very hard to predict, it nonetheless seems like a fairly good guess that human minds are not near the upper scale of what is theoretically possible to do with a brain. Not a squishy brain, but any kind of brain. We know that light speed runs more than 1 million times faster than the speed of neural spikes proceeding down an axon or a dendrite. We know that even though brains still have a huge advantage over transistors in heat dissipation, it's one of the only places where brains are still doing better than transistors, we still know it's pretty the amount of heat dissipated by the brain is still pretty far above the thermodynamic minimum. And we know that the clock speed of a chip and the speed of the transistors on the chip are considerably more than 1 million times faster at this point than neurons, which will fire, say, 150 times per second on a good day. Now, if you consider that it looks, based on physics and neurons, which we understand a bit better than we understand the actual software of the brain at this point, so it does seem safe to say that you could get a million-fold speed up in the rate of thinking that it is physically possible to implement on a physical object without even shrinking the brain, cooling it, using quantum computing or reversible computing or any of that other neat stuff. It should be possible still to get a million-fold speed up, at which rate 1 year, which is 31,556,926 seconds, would pass in only 31 seconds. Or, in other words, the entire span of time from Socrates until now would pass in around 8 hours of accelerated time. We tend to think of the scale of intelligence as if it ran from village idiot up to Einstein, because that's sort of what we experience in daily life. That's actually a very much smaller part of the scale of intelligence that we want to use, which has 0 at a rock, and then comes a lizard, then comes a mouse, then comes a village idiot and Einstein, which are right next door to each other on that slide for a number of very good reasons, one of which is that the village idiot and Einstein have essentially the same brain architecture, the same brain software. There's a few minor tweaks that Einstein's got that the village idiot doesn't, and Einstein has maybe 30% larger brain or something like that. I haven't actually looked up what it was, but it doesn't compare very much to the the difference between a mouse and a human, or a lizard and a mouse. It's not really even on the same scale. I should probably have had those two arrows coinciding. I used the example of the physical speedup, which is easy to analyze, to make the point that biology does not seem to have come close to the limits of what is possible. Software is harder to analyze than hardware, but well, Cynthia McKennion once put it, or Cynthia Kenyon, I can't quite remember her last name, one grad student can do things in an hour that evolution could not do in 1,000,000 years. Biology has reinvented the wheel on a grand total of 3 occasions known to science the last time I checked, because a freely rotating wheel is just something that evolution finds it very difficult to invent incrementally. So the idea that we, which are pretty much the first intelligent beings to show up, we are distinguished by being perhaps the dumbest possible species that can still build a computer. Because if there were any way to do it while being dumber, we would be having this conversation at that level of intelligence. So it's very unlikely that human brains are near the peak of what's possible in software, any more than they are near the peak of the possible any more than it's physically plausible, given the laws of physics, that this is the peak of speed, or the peak of storage, or the peak of thermodynamic heat dissipation. And so I would like you to visualize, in the space of minds in general, the idea that there are possible minds that are smarter than human, and even possible minds that are a whole lot smarter than human, and minds that are not so much post-human as just strange little minds that aren't anywhere near that space at all. You are here, and you want to go there. But that's not really quite part of the talk. I just sort of wanted to put this diagram because it's how I see our place in the universe. Intelligence is the source of technology. We were just talking about using technology to build more powerful intelligence, which closes the feedback loop. This is something that is historically very, very, very unprecedented. For the last 10,000 years or so, we've had, since the invention of agriculture, we've had technology. Something like a door may not seem like technology, but it is nonetheless a significant achievement if you're trying to impede someone's progress or something. But in any case, for the last 10,000 years, we've been improving technology using roughly constant brains. Again, there's an ongoing debate about exactly how much genetic change has occurred since then and whether or not it really matters much on the scale of daily life, but on the scale that runs from chimp to human or from rock to human, the last 10,000 years we've been exerting a sort of roughly constant brain pressure on our technology. There's been more of us. We've invented things like writing. That changes sort of the comprehension of the pressure, but what is exerting that pressure has remained constant. Sorry?
The brain might remain constant, but we're building on top of other technologies, right? That could still be exponential. So like we have Google to search for now, which we didn't have a few years ago, right? So there is still some external things which are speeding us up, right? If not our own brain. Is that not speed up in intelligence in some way, right? As a global
it's certainly the sort of net optimization power exerted by world economy has changed. It has increased greatly over the last 10,000 years because there's more of us. We aggregate our solutions better using things like writing and science. Nonetheless, even if you take 1,000,000 squirrels whose collective brain volume is much larger than yours, you will see that trying to aggregate lots of squirrels, more or less no matter what you do with them, does not quite add up to the same effect as having a single larger brain with very high internal intercommunications bandwidth. It doesn't, no matter how you aggregate the squirrels, it doesn't compare to the improvement in software, whatever those improvements in software are that separate humans from squirrels. So this is indeed one of the sort of attackable joints. Like if you look at the online debates over this sort of thing, it going without saying that I only have time in this talk to present one particular point of view, and so I simply lack the time to present all the other opposing theories, which are in any case so obviously flawed that it doesn't seem worth the slides to expose you to them, and that is why if you actually want to acquire a solid understanding of these things, you should at least understand. You should go online and find out why all the other theories are wrong. Oh yeah. So in any case, the idea, the question of sort of what do we think and what do we think we know, and how do we think we know it when it comes to describing the difference between expanding a single brain or having lots of brains. The squirrel versus human analogy is suggestive, but all it ultimately is an analogy. Sure, Einstein did not have all that much larger brain size. Could you, if you could increase brain size by a factor of 4 and not just keel over, but actually have the appropriate software processes scale up, what could you do that a whole world economy couldn't do in 100 years? Questions like that are, like if you got specific in your answers, I would have to give you a stern look and say, how could you possibly know that? The question of like quantity versus speed, like 9 women can't have a baby in 1 month, and very much the same sort of scaling law applies to computer programming projects or even science. Having 10 times as many researchers is not the same as researching for 10 times as much time. So speed seems to be in some sense more powerful than quantity. There are things that you can do by thinking for longer times that you just don't seem to be able to do by throwing any number of humans at a problem. Aggregation versus speed. Is it better to run a civilization for 1,000 years, or is it better for that civilization to have science instead of just making everything up? On the other hand, maybe not all of the Googling in the world is going to let you do in 1 year what is really probably going to take 10 years. So aggregation versus speed, it's a bit harder to describe the trade-off. Quality you can think of as sort of you have the same problem, but you're generating better solutions to it. But then most of the problems that humans consider are things that chimpanzees just couldn't represent at all. And learning linear algebra will give you the ability to represent a new class of problems that you couldn't even imagine before, not just solve existing problems better. So there are all these. So this is actually one of those places where things break down into much smaller parts than I was actually going to show you in this talk. And I now, oh boy, this is going to run over time. It's going to be your fault. So indeed, there are all sorts of questions as to what we think we know and how we think we know it when it comes to sort of breaking down exactly what it is that has been held constant over the last 10,000 years as the world economy has grown. But nonetheless, I will venture that if you had human brains growing at some sort of in capacity and improving in software on some sort of Moore's Law type curve, the world would look very different than it does today, where these things are more or less constant. The most extreme case of this idiom is an AI directly modifying its own source code. Compared to humans trying to modify themselves, an AI can have complete access to its own internal state, which is digital and can be manipulated with something approaching determinism. It can absorb more hardware. So right now, you're used to thinking in terms of problems that take 1 human, problems that take 100 humans, because it is not part of your present-day option space to take a big problem and solve it using one big human, right? You have to divide it up, and you have to try to throw lots of people at the problem. But again, the squirrel analogy suggests that having lots of people in large, inefficient bureaucracies does not scale in quite the same way as bigger brains. And when you consider that a human brain is something like 4 times too large for a primate our size, and that the neocortex, the most recent stuff, is 6 times larger than the corresponding brain area in a chimpanzee, the idea of an AI that starts out reasonably smart, and then you just add 1,000 times as many processors to it. That's a little different from anything that we have our daily experience with right now. An AI can have understandable code. We can tell the AI how it works because we sequenced the human genome, and we have all been deeply disappointed to find that there are no comments in there. It is still a mess of undocumented spaghetti code. Modular design, like Parkinson's disease, take the affected areas, swap them out, swap a new one in. That's the way we ought to be able to deal with problems like this. But alas, a lot of neuromedicine boils down to dealing with the sad fact that the human brain is not end-user modifiable, and tampering with it can void your warranty. And there's the clean internal environment of a chip. We spend huge amounts of efforts keeping our chips deterministic because we have just no clue how to program chips that occasionally make mistakes. But nonetheless, that's an advantage if you have a piece of code and you think you have a better way to design the code, and you can actually, change it around and have it do what you predict it will do. Things you cannot do in the rather noisy internal environment of the brain. Which brings us to the notion of an intelligence explosion. It was invented by I.J. Good in 1965. Actually, it was invented by a science fiction editor named John Campbell in the 1930s, but he didn't publish it in a peer-reviewed journal, so we will all pretend that this was invented by I.J. Good in 1965. And the hypothesis is that the smarter you are, the better you are at making yourself even smarter, and that the sort of recalcitrance of AI software to being improved does not increase faster than your intelligence increases. So you get a positive feedback cycle, get smarter, make yourself even smarter, lather, rinse, repeat, boom, until you get up to the limits of what you can attain on the hardware. Then you make some better hardware. Then you get up to the limits of what can be done on any hardware. And even if the process eventually tops out, saying that it tops out somewhere is not the same as saying that it tops out somewhere low. Because you see people saying, well, there's physical limits. Well, yes, there are physical limits, but they're way up there. There's a physical limit to the energy output of a supernova, but that doesn't mean you can survive one by wearing a flame-retardant Nomex jumpsuit. And similarly, superintelligence tops out somewhere, but possibly, we don't actually know that, but we would have to be very wrong about the character of physical law for it not to top out anywhere. But nonetheless, the idea is that it nonetheless gets up rather high as a result of this boom before slowing down. Now, because you've probably heard a certain amount of discussion centering around a word that used to mean something, this word is singularity, I do want to emphasize that the intelligence explosion hypothesis neither implies nor yet requires that more change occurred from 1970 to 2000 than from 1940 to 1970. Back when we founded the Singularity Institute, the singularity mostly meant intelligence explosion, not this whole accelerating change business. Most people at the Singularity Institute are skeptics about accelerating change. It is not obvious to us, and we think it is more likely than not to be false, that more change occurred from 1970 to 2000 than from 1940 to 1970. But we don't have a very strong opinion about it because it doesn't actually seem all that important. And nor yet does it follow that technological progress follows a predictable curve. There's what do you think you know, and how do you think you know it? Looks to me like given that evolution was exerting a roughly constant optimization pressure on human brains for the last 5 million years or so, and did not run into any obvious problems in scaling the hardware or in improving the software, and evolution cannot do in 1 million years things that would take a grad student an hour, then even though intelligence presently confuses us, even though there are aspects that are still as mysterious to us as life was in the 19th century, nonetheless it seems like a good bet that if constant evolutionary optimization pressure on brains produce this sort of steady increase in intelligence, that when an AI gets smart enough to improve itself, make itself even smarter, go back, improve itself again, rather than rinse, repeat, the idea is that it seems like a good bet that it will go foom. This is not the same as making a graph of Moore's law and saying that the foom will occur on April 27th, 2035 between 4 and 4:30 in the morning. Knowing that is considerably harder. If I knew exactly how to build a brain, knew exactly how much funding I had to do it, knew how many people I was going to have and who those people were, I would still be unable to predict a project completion time because of general project management chaos. Given that I do not know any of these things, for me to draw a little line and say that something is going to happen in 2035 seems somewhat hubristic. I have no clue when this is going to happen. Now, that doesn't mean it's going to happen a long distance away. It means I widen my confidence intervals. If you don't know how something works and you don't know whether it's going to be easy or difficult to build it once you are no longer confused, perhaps in 5 years we will be no longer confused and the problem, which is presently impossible due to our sheer level of ignorance, will turn out not to be that hard in an absolute sense. And we will see AI in 5 years. I wouldn't put very much probability on it, but I cannot rule it out because I'm ignorant. Perhaps it will require a somewhat longer time than that. I don't know. If you tell me that you know, I'm somewhat skeptical that you know either. Aggressive atheism, isn't it wonderful? We may nonetheless be underestimating the speed at which current AI is progressing, because anything that is dumber than a village idiot merely looks to us stupid. We don't really have the ability to watch the let's see. This is, what is this? I don't even, okay, this was supposed to be animating over here. Animate, curse you, there we go. And the idea is that there's this AI arrow slowly creeping up at a steady pace, and that in answer to the question, when will we get human-level artificial intelligence, I cannot tell you April 27th, 2035 between 4 and 4:30 in the morning, but it does seem like a somewhat better guess to say, when will we get human-level intelligence? For around 2 weeks before it goes off the other end. The absolute distance between village idiot and Einstein not being all that large. So if you can push it all the way up to village idiot, pushing it out past Einstein may not be all that much harder. Of course, the intelligence explosion hypothesis says that you should not find that there's a sort of constant optimization pressure. There should be this whole slow regime where the humans are pushing on the AI and it's going along at the human rate, and then when the AI is smarter than us, it should start pushing on itself and zip off the right end of the slide. But from our perspective, it actually probably looks pretty much the same, amusingly enough. Same result. It just doesn't spend very much time at the human level. So, in my humble opinion, one good way of spotting futurists who have not necessarily thought very deeply about these issues is that they spend a lot of time talking about, quote, human equivalent artificial intelligence. It's a sort of humanocentric view, anthropocentric, this idea that the human level is special, unique, distinguished. Well, it's a special threshold. But talking about AIs who spend a lot of time at that exact level of intelligence, well, what privileges it? What distinguishes it? Why focus in on that area of the graph and suppose that that's like the most interesting area of the graph for an AI to stay? Now, if you have an extremely powerful superintelligence, it can make technology. We have a question from the audience. If I'm late, it's going to be your fault. Now, speak.
I would be intrigued to know, how can you expect minds to be able to create another mind that is smarter than itself? Or is there any intuition you can give in theory? Because otherwise you can as well expect diminishing returns and say, okay, there's this saturation effect, so we can't possibly create something that's more complex than ourselves. And in that moment, if you believe that, then of course we cannot possibly create artificial intelligence, at least deliberately, that's smarter than us.
All right, so I have a question about the audience's utility function. How many people think that's a cool question? I should actually quickly close this down, open up some other slides, and answer that question, which will possibly result in those of you who attempt to stay through the entire thing staying a little longer. And how many of you want to make sure you want to get on to the pub on time? To the pub on time. Show of hands. Quickly open up the other PowerPoints. Show of hands. All right. Today's pub fails. All right, so, come on now. I wonder if I can actually get away with this with Microsoft. What's my computer doing over here? Hold on. This AI here is getting rebellious. Okay. No. All right, let's just go to right over. Here we are. So there's a parable I sometimes use to explain some of the confusion in modern AI by saying, suppose that people had no idea how addition worked, or even what addition was really. And so they tried to program artificial adding machines by using a database of first-order logical facts, which of course means that there are lots of little suggestively named Lisp tokens with names like 13, and it knows that plus of 7, 6 equals 13. It knows that plus of 9, 6 equals 15. It knows that plus of 7, 2 equals 9. But there's no way to get from the first three facts to plus of 13, 2 equals 15. We have to enter in that fact independently, because no one really knows how addition works. And so you have lots of views on artificial general addition, like it's a framing problem, what 21 plus equals depends on whether it's plus 3 or plus 4. We're going to have to program a huge network of arithmetical facts to cover all the common sense truths AI needs. Or you need an artificial arithmetician that can understand natural language, so instead of being told that 21 plus 16 equals 37, it can obtain that knowledge by reading the web. Or we need to develop a general arithmetician the same way nature did evolution. Top-down approaches have failed to produce arithmetic. We need a bottom-up approach to make arithmetic emerge. We have to accept the unpredictability of complex systems and realize that even if we make AIs that can do addition, we may never really understand how they add. Or maybe we should use neural networks, just like the human brain, which can be trained to do addition without our understanding how they work. This makes them wonderfully mysterious, you see, rather than being a reflection of your own stupidity. Neural networks will do arithmetic without we, our creators, ever understanding how they really add. Or we need calculators as powerful as human brain, which Moore's law says we'll get on April 27, 2031 between 4 and 4:30 in the morning. No, that's not enough. We have to simulate the exact neural circuitry humans use for addition by scanning human brains. Gödel's theorem shows no formal system can ever compute the properties of arithmetic, and classical physics is formalizable, so clearly an artificial general arithmetician must exploit quantum gravity. And not to mention that if human arithmetic were simple enough to program, we couldn't count high enough to build computers. And haven't you ever heard of John Searle's Chinese calculator experiment? No, we'll probably never know the nature of arithmetic. The problem is just too hard for humans to solve. This is what people sound like when they are confused. We need to learn to recognize what people sound like when they are confused, not mistake it for actual knowledge. So, for our purpose, the point is that entering an infinite number of surface cases means you didn't understand the underlying generator. And suppose you asked, like, how can a human build a chess-playing AI? You might think that the way to do it was to have a human look at a number of different chessboards and say, what is a good move to make in this situation? Now, there's two problems with this. The first is that if you build a chess-playing AI this way, it will never play chess any better than you do. It will never make any move you didn't see yourself. And the second problem is that there are simply too many possible chess positions to ever program explicitly. So what you need is the insight which says, okay, instead of making this chess AI try to play the same way we do, we are going to make it perform a sort of abstract high-level work that humans are performing, only this is going to perform that work better. So humans experienced no difficulty, or pardon me, we experienced a certain amount of engineering difficulty, but we'd experienced no philosophical difficulty in building an AI that played better chess than any human. And by now, the chess AIs are probably up to better chess than any human could play, one would guess, unless they sort of dip back down after Deep Blue 2, which I suppose is possible. So the moral of the story is that if you are not trying to program an endless database of facts where you don't understand how you yourself obtain them, if you are programming the underlying generator, then to improve that generator is a different sort of task than looking at a particular chessboard and saying, what is a better move? And the answer to your question about how you can build something smarter than you is that once we have opened up the black box and looked at the algorithms, then to understand what those algorithms are doing and how to build better algorithms is not the same as trying to imagine a chess move that is better than any chess move you yourself could make. You're trying to imagine better cognitive algorithms than evolution burped out over the last few million years. And the thing to remember about evolution is that the marvel of evolution is not how amazingly well it works, but that a process with zero intelligence, no look ahead, and completely random mutations works at all. That is the wonder of evolution. And it's an important thing to emphasize if you're in America because we have a bunch of loony creationists down there. But if you try to sort of like get back at the creationists by praising evolution to the stars and saying how it constructs things better than any human could, you're missing the point. The point is that you can have the sort of totally accidental processes that works, not necessarily well. And at the start of the start of this presentation, you'll recall I showed you a particular example of human brains making this really silly malfunction, assigning more probability to more detailed future scenarios. So the software can certainly be improved. It's the sort of thing that happens when evolution burps something out, not when human engineers carefully design something. When human engineers carefully design something, that goes wrong in different ways. So if you had an AI that had a little tree like this that played chess, and an AI that also had some ability to reprogram itself, and humans had not written a very good search tree, then for the AI to make itself play chess better is not actually paradoxical. Its ability to write code reaches in and rewrites the game-playing tree, and it wouldn't actually be any different if it was rewriting the part of itself that rewrites code. So there actually is not any more philosophical difficulty with an AI building a smarter AI, or humans building a smarter than human AI, or any more than there is a difficulty with building a skyscraper that is taller than us, building a chess player that is better than us. The saying, Einstein's mother must have been one heck of a physicist, demonstrates the generic flaw with this level of reasoning, and ultimately the only answer I can give you is that it is merely not philosophically prohibited. Does that satisfy you, good sir? No, we have another question. The pub gets later.
I think you're just forgetting that in order to evaluate itself, chess AI also has to run its modified version in order to assess whether this change is actually useful or not. And this makes it really, really hard. So you can't just
Why
have
does
a chess AI or any AI that says, oh, I changed this. And maybe it makes things worse. Maybe it makes it well or better than for the first 1,000 iterations or games. But then it makes it far worse afterwards.
Well, if you're making random changes, then you would have to test all of them. In point of fact, there are all sorts of things that are predictable. Just by looking at, say, alpha-beta search, I can predict that it's going to work a bit better than pure min-maxing. If I add more processing power to this tree, it will predictably improve. If you don't think that is true, at what odds would you care to bet against me on that? And there's all sorts of features that are predictable improvements, some of which need to be tested, some of which are strongly predictable even in the absence of testing. I'm not quite sure what else there is to say about the philosophy of it. I hope that was a satisfying answer.
So I guess the trick with this chess was also that if I was able to run this program, I would do it, right? It's just that the human mind, so this is this algorithm that you stated, the generating algorithm, but the human mind cannot run it. Otherwise, the human mind would be as powerful as the chess. So I guess that's
Sure,
also
unless the chess player was simply larger, or
Sure.
had better serial speed, because
Yeah,
the
exactly,
human
yeah.
neurons are running at 200 hertz, and sure, there's 100 trillion synapses in there. But
So-
remember, if your computer ran at 200 hertz, it would also need 100 trillion processors just to get anything done in real time.
Right.
So yeah,
So we have an algorithm which we can't run ourselves, but we can run it on a computer, so that's why it's kind of better, right? And that's one
right. Although even then, even if humans were self-modifying, they could still build better hardware, and then the better hardware would use hardware. But in point of fact, humans are not self-modifying at all, so we can use none of these amazing things that we invent for the delectable use of AIs. And that was the answer to that question. Now, can I get out of here? All right, yes, I can. I can now go away. I can bring this back and so supposing you have a superintelligence, how long would it take to get nanotechnology? Here's a way you could get full-scale, Eric Drexler-style molecular nanotechnology in merely 10,000 years. You need to be able to solve a special case attack of protein folding. That is, you don't have to solve the general protein folding problem for biology. You just need to solve a special case of it with respect to some particular space of amino acid strings. There are nowadays online labs, in fact they've been around there for a while, where you can email them the DNA and they will sequence the DNA, synthesize the corresponding protein, and FedEx it to you or courier it to you, and some of them boast that they have 72-hour turnaround times. The proteins self-assemble to some primitive device that takes acoustic instructions, say, like it's the equivalent of a ribosome. And you use that device to build second-stage nanotech, which builds third-stage nanotech, etc. And the total time is 10,000 years, or at a 1,000,000 to 1 speed up around 4 days or thereabouts. Actually, it's not consistent with what I said earlier, so I wonder which of those two calculations was correct. That's probably not important. Anyway, the point over here is that you think of it as being like a brain in a box, and you say, well, like it doesn't have any money, so it'll be all that powerful. The thing to remember about that is that money did not grow on trees, and humans, when they were roaming around in the savannah, did not find supermarkets where they spent money. Money is something that we sort of created to help us keep track of the book, to help us do our bookkeeping. And while we were making the technology, that actually took us a bit less than 10,000 years to invent once we really got going. So this is one way I can think of for a superintelligence to get from incredible brain power to incredible manipulate the real world powers. But this is merely my intelligence doing it, so perhaps there's some way to get it done in less than 10,000 years or 4 days or whatever it is at the internal speed up of the superintelligence. Now, you're wondering, if we have this superhumanly powerful intelligence, armed with full-scale molecular nanotechnology, or maybe even something better than that. I mean, who says molecular nanotechnology is there's a limit of what you can do? And it's very powerful and very smart. How could this possibly not be a good thing? It's at this point that I would like to introduce a little error in reasoning that I call the fallacy of the giant cheesecake. There is a lot of reasoning you will see about these sorts of futuristic scenarios that run something like this. Major premise: a superintelligence could create a mile-high cheesecake. Minor premise: Moore's law continues to deliver us larger and larger amounts of computing power. Conclusion: the future will be full of giant cheesecakes. Of which the lesson is that power does not imply motive. Dun dun dun. Cheesecake's coming to get ya. So the question one might ask is, what will these superintelligences want? Now, I was actually called over here for the Winter Intelligence Conference, and the main point of that talk was to convince people that, contrary to whatever solution has instantaneously sprung into your mind, it is actually not a trivial problem. We tend to assume that we know what other minds want because in our daily work we deal exclusively with humans, and there's a certain amount of commonality in what humans want. There's this lovely little book called Human Universals. I never read it, but I read the long list of human universals that was taken out of that book and put into Steven Pinker's The Blank Slate. And these are some of the things that have been found in every known culture studied by anthropologists. Tool making, tools to stab things, grammar, tickling, meal times, mediation of conflicts, dance, singing, personal names, promises, mourning, and this list goes on for quite a while. Because we are all running the same engine under the hood, even though we may be painted different colors. Why is this the case? Or actually, you know what? I'm not going to tell you why this is the case because I can safely skip over this section of the talk. I'll just give you a few moments to read it. You're fast readers, right? And the moral of the story is that complex adaptations have to be universal within a sexually reproducing species, because if something has 6 genes necessary for it, they're each at 10% frequency in the population, then only 1 in a million people will have the complete adaptation. Complicated adaptations take time to evolve because basically all the other pieces have to evolve to universality before you can have a new piece that depends on all those other pieces. This is why the X-Men are remarkably implausible, because if there was a single mutation that could give you the ability to generate electricity, be immune to that electricity yourself, and control it well enough to throw lightning bolts, so that this whole ability appeared from scratch in one generation, that would actually falsify the theory of natural selection as thoroughly as J.B.S. Haldane once said when he was asked if evolution was falsifiable, finding rabbit fossils in the Precambrian. And when you apply this principle to cognitive adaptations, you get what is called the psychic unity of humankind. The brain is a complex machine. If there were whole complex machines inside the brain that were only prevalent in 10% of the population, then the genes for them would never assemble. So at any given time, natural selection, or just sort of genetic variation in humans, is this sort of small surface froth on this deep well of pre-established complexity. You can have little variations in the machine being selected on. And there can be people who have had whole bits of complex machinery knocked out of their brains. You can't have whole new complex adaptations that some people have and some people don't. That doesn't happen within a sexually reproducing species. And that, in turn, explains why the human universals list is what it is.
So if we just duplicate ourselves, it would be different, right? So your main argument, so you're saying that because both the parents need to have these common traits, these adaptations should be universal because they would not propagate to the next generation.
Well, I'm saying that human beings all work the same basic way.
Right.
And this causes us to be a bit overconfident in our predictions of other minds. We anthropomorphize. That word feels like it should really be a bit longer, so it would roll properly off the tongue. For example, the Matrix. There are these evil AIs. In the beginning, they're supposed to be emotionless, Mr. Anderson. We talk in emotionless drawls, which is how Hollywood scriptwriters indicate emotionlessness. However, because Hollywood scriptwriters can only model AIs as emotionally repressed humans, Mr. Anderson, as soon as I am feeling strongly about something, I will begin to acquire facial expressions and my voice will acquire tone. And my face will make the same humanly universal expression of disgust, say, or anger, that is found in every known tribe, because it's a human actor and a human scriptwriter. So this is anthropomorphism. Anthropomorphism can actually get pretty subtle. Here is a painting of a type that used to decorate science fiction way back in the old days, back when science fiction writers were actually stupid sometimes. They tend to be a bit smarter now. But back in those days, what could possibly have been going through the mind of whoever drew this painting? It probably went something like this. This girl and I also like to observe that for some reason they never show the gigantic bug carrying off the human male in the torn shirt, and they also don't show the human male carrying off the bug in the torn dress. So what's going through the artist's mind perhaps is something like this. This woman is attractive. That is, she is inherently attractive. This is a property of the woman herself, you see. That old mind projection fallacy again, like thinking that if you don't know whether a coin is heads or tails, there's some sort of 50% probability that's an inherent property of the coin. So this woman is attractive. Therefore, the swamp monster is attracted to her. Where the evolutionary history of the swamp monster, well, what does that have to do with anything? So there's all these sorts of if you hit an AI, wouldn't that get angry at you? Because that's sort of an inherently angering event. And the answer is that it's not that these sorts of emotional reactions are not properties of the events, they are properties of you. I don't mean to say this in any sort of psychoanalytic way, just to point out that within the vast space of possible minds, you could construct minds with different motivations than the human. Or for that matter, you could simply have different motivations than the human. Not necessarily because you designed them that way, but because you just threw something together. Now, there's sort of to predict a smarter mind, you'd have to be that smart yourself. I'm just going to skip over this again. And say that what we want to do then is, given freedom of design, we want to be able to reach into mind design space and pull out a friendly AI. And the idea behind a friendly AI is not to predict that all AIs will be friendly. It's not to tell stories about AIs being hostile. Futurism as a branch of entertainment is about storytelling. But futurism of the sort that is actually useful is about saying how the outcome varies depending on its initial conditions. So it's not a storytelling problem to say how AIs will be, it's an engineering problem to predict which kinds of AIs have which kinds of properties, pull into the space and pull out an AI we would actually want to build. Actually, I think I just ordered these slides incorrectly. Now, you might object that you couldn't possibly predict that a smarter mind would have any sort of benevolent motives, because if you could predict what someone smarter than you would do, you'd have to be that smart yourself. For example, if you could predict exactly where Garry Kasparov will move on a chessboard, you must be at least as good a chess player as Garry Kasparov, because you could always just do whatever Garry Kasparov would do in a given situation. Deep Blue's programmers, that's the chess-playing program that beat Kasparov, couldn't predict its exact moves. And indeed, if they could have predicted its exact moves, it would necessarily have been no good at playing chess than they were. So, given that a smarter mind is unpredictable, why not just use a random move generator? That will be very unpredictable and therefore very smart. The unpredictability of a superior intelligence is not quite like the unpredictability of coin flips. In particular, let's say that you've got a chessboard and you're trying to predict where Deep Blue would move. You could have a probability distribution over where Deep Blue would move, and that probability distribution could be well calibrated in the sense that moves you thought Deep Blue had a 1/10 probability of making would happen about 1/10 of the time. Trivial case, you predict all legal moves with equal probability, and then your probability distribution is trivially well calibrated. Not very discriminating, but trivially well calibrated. So, on the other hand, if you sort of took your probability distribution over where Deep Blue would move and made a random move from that probability distribution, the resulting mind would probably play very poor chess. It would it would occasionally randomly make very bad moves and would probably end up losing the game. So, your belief about Deep Blue, clearly, is not summarized by your belief about what move it will make next. What do you know about Deep Blue that you don't know about the next move it will be making? Well, you can guess that it will win the game, especially if you're not Garry Kasparov. So the unpredictability of a superior intelligence is not like the unpredictability of coin flips, because the unpredictable local moves have predictable distant consequences. The programmers could look at the search tree built into Deep Blue and say, I can't execute this search tree inside my own head. I don't know where exactly it's going to move on the board, but I am quite confident in my statement that this AI is trying to steer the chessboard into winning regions. And because this is a sufficiently powerful AI, I repose some confidence that it will win the chess game, especially if it's not playing against Kasparov. So this sums up the idea that a friendly AI is not one whose immediate moves you can predict. It is one that predictably steers the universe into nicer regions of outcomes. And when the AI modifies itself, it would not be trying to prove what move it would make next. It would be trying to prove that it was executing a similar sort of search for nice outcomes. Now, if you're going to ask me, what do you mean by nice? That would be a whole separate presentation. But to sort of quickly convey the depth of the problem, suppose that ancient Greeks had tried to build an AI and they tried to give it their own, what their society said was morally good goals. Like, a glorious death in battle is the greatest thing a man can achieve. And I'm using deliberately sexist language because they didn't think all that much of women necessarily. It was before the 1960s. So if we were sort of looking back in time and we wanted to give Archimedes a bit of advice, like say that the AI problem had been a bit harder and so Archimedes had been able to solve it, we wouldn't have told him to build his own goals directly into the AI. We want, in some sense, to design the AI that follows the sort of trajectory of this mysterious stuff called moral progress that took place between now and ancient Greece. But ancient Greece didn't actually know in advance where they were going. As the saying goes, in the art of rationality, if you know your destination, you are already there. And it also wasn't a set of random changes either. And I'm just completely not going to address that question at all. I'm just going to, sort of hopefully block off the failure mode where you say, ooh, democracy is good. Let's build an AI that likes democracy. because that is exactly the same sort of general behavior you would have advised Archimedes to stay away from. And I'll actually just end my talk there and hopefully have conveyed to you that this was a surprisingly short talk, considering how long it went, and that the conversation continues at any of these 3 websites over here. Thank you.
Time for a couple of questions.
Questions? Are you saying that this talk was not fully, did not cover all possible questions that could arise?
Well, we'll see.
Do you have a definition of intelligence or a set of necessary rules?
Okay, so I tend to view intelligence as efficient optimization. You ask me, what do you mean by optimization? By optimization, I mean the ability to steer the future into regions high in your preference ordering. And you could even try to say quantify optimization by saying, this is how good an outcome I got. This is the space of outcomes that would have been equal to or higher in my preference ordering than that one. This is the measure, or this is the count of the total space. This is the fraction of that space, relative to my preference ordering that I managed to steer the future into. Like, I got an outcome that was better than all but 1 in a million other possible outcomes. I now take the log base 2 and say that I exerted 20 bits of optimization power. Now evolution exerts a lot of optimization power. It is able to make complete butterflies over the course of a few billion years, but it's not very efficient. It does it by massive, truly ridiculous amounts of trial and error. So intelligence, you might say, is computationally efficient optimization. And if we then want to talk about what makes human intelligence sort of interestingly different from chimpanzee intelligence and its ability to handle lots of different problems, we would say that general intelligence is efficient cross-domain optimization, because it is able to do consequentialist reasoning that chains actions and strategies through many different sorts of possible domains of application. Did that answer all your questions, sir?
But couldn't you have something that not efficiently optimizes completely unintentional or accidental, so they're monitoring objects that accidentally optimize something efficiently, and then you call that thing intelligent?
You could, but it wouldn't compress the message that you were using to send to describe it, because there wouldn't be any simpler way to describe the ends that it was achieving than by directly describing the ends themselves. Whereas if I have, say, a robot car that no matter where it starts in the city, it will use its model of the city to navigate to the same final destination, then I can send a compact message describing the car's behavior, saying, this is where the car goes. And on the other hand, if I have a car that is turning at random, then every time I want to talk about the car, I can't say it's going to the same place each time. I have to redescribe where it went each time. So to invoke the concept of intelligence will only compress the message you use to describe the behavior of a putatively intelligent agent if it is exhibiting coherent, goal-directed behavior with a compactly specifiable preference function. Next question.
I have a question in 2 parts about inspiration. Because you argued early on in your talk that we shouldn't think that intelligence is limited because the brain is far from being, physically optimal in the sense of a lot of parts and stuff. But if you say take Einstein, surely what made him quintessentially a genius was not necessarily that he forecast or knew more, but he came up with new ideas which nobody else even came close to coming up with. So this ability for inspiration seems to be a very important quality of a useful intelligence. And so I was wondering, did you have any ideas about how the physics of the brain would relate to that ability of inspiration? And sort of the second related part is, you argued that one kind of super intelligence would be a lot better than many quite smart intelligences. But we know that for human minds, one human mind, even a brilliant one, can't get stuck in its ways. And if you have many minds which can come together, then they can share ideas and induce new thinking in each other. And might that be a better way of creating new ideas than just having one big one?
To answer your questions in order, and it's quite possible that I will forget the second one by the time I finish answering the first one, you'll have to remind me. I put to you that creativity is not randomness. It may be something of which, a lot of times randomness is sort of the mind projection fallacy version of something of which we are ignorant. It seems unpredictable, and so we assume that unpredictability is an inherent property of the thing itself. But if you take a random number generator, you'll have to wait a very long time for anything creative to get out of it. I put to you, therefore, that if we were to try to formalize, I put to you, therefore, that if we were to try to formalize what it is that you are recognizing when you recognize creativity, it would be a solution that is high in your preference ordering, but low in your search ordering. So, in particular, if the solution violates what you thought of as surface constraints, someone builds a car only instead of having square wheels, the way that you thought all cars must have square wheels, it has round wheels instead. A rule has been violated, and because your thought patterns would usually follow that rule, it would have taken you a very long time to think of a car with round wheels. It is a solution that is high in your preference ordering. The car works very well. It travels much less lumpily. But low in your search ordering, it violates the rule that cars are supposed to have square wheels. So how did Einstein's brain come up with solutions that were high in the preference ordering, or in the case of his scientific theories, well confirmed by the evidence, but low in other people's search ordering? Well, that is a difficult question.
That could be random.
But it can't be random because it would take too long to get there.
No, becoming an Einstein could be random.
Well, I'm not quite sure what that sense of the word random is intended to mean there. You mean that Einstein was randomly himself rather than someone else? Let's not get it.
Someone came up with it, so you have a lot of people, and it's random, and he came up with it.
Well, for special relativity, yeah. But then he pulled it off again with general relativity. That was just cool. You know, you can easily imagine an alternate history of the world where it took them like another 70 years or something to come up with general relativity, and people are going like, how could we possibly have guessed that without all this experimental data to narrow down these complicated equations? And Einstein just, he goes, well, how would I have designed this universe? And pulls it out of the hat. Awesome guy. And if I knew exactly how to build an AI that did what he did, I would be, like, easily 5 years further ahead in my research.
Would you define any algorithm, any deterministic algorithm, as some trajectory in service on the utility function? So, if you define intelligence like a creative group as not early on in my search, in my direction search, very high utility, then this must inevitably mean there's some randomness.
No, it actually means is that I do something that looks incredibly creative to you. Or vice versa, to be fair.
Well, okay, just about kind of randomness, right? Randomness doesn't mean it's a flat. Probability distributions kind of
They're
useful.
So in general, the useful parts of the system are not the parts producing snow on the television screen. I mean, there's actually a whole long lecture on this point about analogies between the second law of thermodynamics and cognition, showing like I'm trying to, like, if you had an AI, like, except under very rare circumstances, if you had an AI that was engaging in a quote random search, and there was a computer program which said, make a move from this probability distribution that goes 10% to doing this, 50% to doing that, 30% to doing that, 10% to doing that, and this program was not working as well as you wanted, you would not search for a pure source of noise. You would tweak those deterministic percentages. The part of the system that is doing useful work and the part that is snow on the television screen are actually very distinct. And again, there's this whole discourse here on unrandomizing algorithms. Like there's this idea that there's this certain people who believe that for any randomized algorithm you can show me that isn't explicitly trying to be opaque, there is a unrandomized version that does the same thing, although it might be that does the same thing better, even though it might be more computationally expensive. But that gets us into a whole long lecture on on the futility of emergence, etc. You can Google the futility of emergence, and you will find the relevant What's Wrong blog post. Or the futility of randomness. I think we'll also get you that one. But I guess that all sums up to an argument from authority, because I don't actually have time to go into it at all. So what was the second part of that question?
My question. Is it better to have one super intelligence than many?
Right. So the thing about humans is that, again, like you have smarter humans, but you do not have humans that are with 10 times the cranial capacity of any other human. So you just cannot scale up in the way that a superintelligence can scale up. You have no experience with that. And in general, like more bandwidth is going to be better than less bandwidth. And as the bandwidth of intercommunicating processes approaches all the processes being neighbors of each other, the resulting agent would, I expect, approach a single mind. And your particular example was the human gets stuck. I think that is best interpreted as an emotional problem of humans being stubborn and politically attached to their ideas, not as a general demonstration that minds in general will, be obstinate old scientists who have to die off for the next generation. For the next generation. Oh, there's this lovely saying. How did that saying go by Max Planck? Scientific ideas do not triumph because they convince people, but because the old guard dies off and a new generation of grad students grows up familiar with the idea. I love this saying because it implies that the actual power of science to distinguish truth and falsehood resides primarily in grad students learning the material for the first time, because all the grown-ups are too stubborn to change their minds once they've already learned something. But that, I say again, is probably just the human way of doing things and being politically stubborn and so on. Let's go for one last question. Yes, you.
Hi. So I really like the analogies you gave, for example, the chess game and the car finding its way to a particular point in the city.
Thank you. That's a
but it strikes me that they have quite obvious end goals, like that the king is going to be can't move where it can't be taken in the next move, or there's a place where you can say this is definitely the place I want to be. So what sort of, when you talk about trajectories for kind of and these optimization functions, what would you suggest? Could you talk about which trajectories you might send these intelligences towards? It's not clear to me what would be good, what would be inherently good, and what would be inherently bad, or what would be a goal or an outcome to kind of work towards.
Can I tag along with this question and just ask you to design an AI that can defeat the second law of thermodynamics? That would just solve all the problems.
Yeah. Well, no, it actually wouldn't solve all the problems, but it would resolve all the thermodynamics-related problems. And if wishes were horses, I mean, the second law of thermodynamics, maybe, but I'm not quite sure what else to say about that. So you asked. So this is one of my all-time favorite sentences, and it's a great sentence to read whenever you're feeling sad. It's a list of things that have terminal value. That is, these are things which are valued not for their consequences, but for their own sake. Life, consciousness, and activity, health and strength, pleasures and satisfactions of all or certain kinds, happiness, beatitude, contentment, truth, knowledge, and true opinions of various kinds, understanding, wisdom, beauty, harmony, proportion in objects contemplated, aesthetic experience, morally good dispositions or virtues, mutual affection, love, friendship, cooperation, just distribution of goods and evils, harmony and proportion in one's own life, power and experiences of achievement, self-expression, freedom, peace, security, adventure, novelty, and good reputation, honor, esteem, etc. Even if you program all of that into an AI, and you set the correct relative values, and you get everything that William Frankena managed to leave off his list, that might still not be enough to get, like a properly nice AI. but it would be a lot better than programming it to, like produce happiness or something. Because then you would get the dreaded super happy maximum fun device. So the actual sophisticated modern day FHI Singularity Institute proposals for handling this sort of thing tend to go along the lines of, instead of trying to program all these things explicitly into the AI, set up a more structurally complicated utility function that looks at current humans, reads off their decision systems in detail. That is, in other words, instead of trying to program these all exactly right, instead of building a painting, you're going to build a mirror. You're going to point the AI at humans and say, you see those things? That's where your goal function is. Then you figure out what the human decision functions are. You try to transform them to get closer to reflective equilibrium. In other words, it's not what you would decide right now, it's what you would decide if you knew everything the AI knew, thought as fast and could consider as many options and search abstractions as well as the AI does. In other words, you can generate solutions that are as good as the AI does given a given criterion. You had no unwanted weakness of will. You had like better reflection. This gets you closer to what would be termed in modern moral philosophy reflective equilibrium. And then you could take the superposed reflective equilibria of everyone in the world, and there might be multiple possibilities for what people could end up deciding. And when there's a lot of coherence in the superposition of everything that people might want the AI to do if they were smart as the AI, that's what the AI does. And that's known as coherent extrapolated volition. And it is an example of what Nick Bostrom would term indirect normativity, because instead of directly knowing exactly what the AI is going to do and saying that it's good, we're going to build some system such that we believe that when it executes, it is normative. And I did see another question, but we should probably hit the pub. And by that I don't mean